I know some of you are sticking around. I want to give you lots of time here. So, next question.
Wait, we didn't finish the other one.
We didn't finish the other one.
Do we need to finish it?
No, it's still 5.
You can multiply that.
You multiply that times 1.6, but we don't.
Yeah, I'm just going to say, I'm going to tell you that you already did that on the previous problem, and then you just divide it by 1. Oh, you want to know the final answer? Answer 3. Okay. Look over here. 10-meter length of copper wire at 20 degrees Celsius. The radius of the wire is this. Here's the cross section. So we've got the radius. Calculate the resistance. Okay. We've got a formula for resistance. Rho L over A. All right. How are we going to figure out what rho is?
Rho is 1.72 10 to the negative 8.
Yep. 1.72 times 10 to the negative 8. That's based on our chart. What's the length?
Times
10 meters. What's the area?
10.
Pi r squared, because it's a circle. So pi times the radius squared. So I'll put in parentheses 1 times 10 to the negative 3 squared. Okay? If you do that, you'll get a final answer of 0.05 ohms. I trust your calculator skills. However, I don't trust them all the way. Make sure you do numerator, enter, denominator, enter, and then numerator divided by denominator. So you tend to put the slash right there. Okay? It's just an application of that formula. Alright? This one we should get no problem. A copper wire at 20 degrees Celsius has a length of 10 meters and a cross-sectional area of this. The wire is stretched, becomes longer and thinner, and returns to 20 degrees Celsius. What effect does this stretching have on the wire's resistance? Does it increase, decrease, or none at all? So, remember your formula. Resistance equals rho L over A. What did we change? The length. We increased it. How's that going to affect the resistance? It's going to go up. Numerator, direct proportions. Great. Almost done. Pieces of aluminum, copper, gold, and silver each have the same length and the same cross-sectional area. Which wire has the lowest resistance? Well, I don't know. It depends on the formula. There's the formula. We're looking at rho, okay? So it says the lowest resistance is going to mean the lowest rho. Who has the lowest rho out of those? Aluminum, copper, silver. 1.5 times 10 to the negative 8. I like it. See, it's just, y'all getting a feel for these formulas? All right, let's wrap it up here. A particle could have a charge of this, this, or this. What do you mean it could have a charge? Well, remember, are you allowed to have like 1.5 electrons on something? No. Now, what about 2.5 protons? No. It has to be a whole number of electrons or protons. Okay? So it would have to be a whole number of 1.6 times 10 to the negative 19. What I mean is, one electron is 1.6 times 10 to the negative 19 coulombs. That means you could have 2 electrons, or 3 electrons, or 4 electrons, but you couldn't have anything in between that. 2 would be 3.2 times 10 to the negative 19. Is that an option?
Yeah.
Boom. There you go. It couldn't be this one because that's less. It couldn't be this one because it's still less, 1.6. And it can't be this one because it's not a whole number multiple. The next one happens to be 4.8 times 10 to the negative 19. All right. Is this the last question? Great. 2 small identical metal spheres, A and B, are on insulated stands. Are given a charge of 2 times 10 to the negative 6 coulombs each. 2 times 10 to the negative 6 coulombs. 2 times 10 to the negative 6 coulombs. The distance between the spheres is 2 times 10 to the negative 1 meter. That's the radius. Calculate the magnitude of the electrostatic force that the charge on sphere A exerts on the charge on sphere B. Does anybody know a formula that would help us out with this? Figure out what's the... What's that?
K.
K.
Q1 and Q2.
Yep.
Over R squared.
Does anybody remember the name of that formula? Coulomb's law. All right. All right. You can look up K. Q1 and Q2 are these values right here. Q1, Q2. R is the distance between them. Oh, just so somebody let me know. What is K?
9.
9 times 10 to the 9th? Yeah, there you go. Multiply this by this by this and divide it by the radius squared, you'll get your answer. In case you're wondering, it's 0.9 newtons. Your quiz tomorrow will cover all of these possible formulas. Coulomb's law, Ohm's law, the definition of current, the resistance of a wire, okay, parallel and series resistors. Okay? You will be able to work together. We'll see you then.